Okay, hello and welcome to the first video of the intro to VOPs episode. In this episode, or this part of the tutorial series, we're gonna look at VOPs, specifically attribute VOPs and point VOPs. VOPs is a visual way of coding and doing math in Houdini. You can do things like VOPs with the actual code called VEX. But I just found it easier to do it in VOPs, and I think it's more easily adaptable and learned when you're starting out. So I'm gonna teach you a little bit about that. So, for example, one. In this example, it's very simple. We're just gonna have a point cloud. So I'm gonna switch to scatter here. We have first a sphere. We make it into a volume, and we scatter some points. So with these points, as we remember from the points tutorials, the points now have a PT num and they have a position. Every point has a position, and we can double check this by going to the scatter and going to geometry spreadsheet, and we can see that px, py, pz all have values for every single point, and they are all different and kind of random in a spherical matter. But anyway, so what I want to do with this VOP is I want to add and I want to subtract from this position, and I'm going to show you how to do this, how to transform things with the attribute VOP and how that's done. So let's dive into this node here, VOP add subtract, and take a look. So this series is also going to be the same, there's going to be notes, there's going to be explanations for everything. So if you want to go through it without watching the videos, that's totally fine. You're going to be able to do that. Anyway, so looking in here to begin with, I'm just going to go over slightly at first how the VOP works, right? So looking into it at first, this is all you're going to be greeted by: the geometry VOP global and also this geometry VOP global output. These are the only nodes going to be in here to begin with. So what this is, it's basically all the attributes exposed to you that the geometry, the upstream geometry has on it or can have. So it has position P, V for the velocity, force, which is also a vector, age, life, identity or ID, color, CD, UV, which is UV, N as in normal. It has the time, the global time, the time increment, the frame you're at. So currently you're at frame 1, so this would be the value of 1. It has a PT num, prim num, which is a primitive number. It has a vertex number. It has a num PT, which is a specific point. No, actually that's the total amount of points that you have. So right here we have, I'm gonna guess we have 1,000 points. So the num PT would add up to 1,000. Primitive num primitive is also the same, but for primitives. So we would have the total number of primitives. Number of vertices or vertex is the number of vertices as well. And here you have the input 1, input 2, input 3, input 4. So if you take a look at the VOP up here, you see it has input 1, input 2, input 3, input 4. So we can actually access multiple different geometries and do things with them. But keep in mind that the first input is always the geometry that is outputted. So you can't output multiple geometries. You can only output the geometry that goes into input 1. That's what's going to come out of here. But you can use other geometries for other things to multiply things and to add attributes to things and mess around with that. Anyway, back to what the tutorial was about. So now I can explain what this is, sort of. So as you can see here, we grab the position because we want to add things onto these points. These points now have a position. We want to add and we want to subtract from this. This is two different things we want to do. So, excuse me. In the VOP, we have a multiple amounts of nodes that we can use. Most of them are math or functions and kind of this trigonometry, sine, cos, these kind of things. If we press tab, we can see that we have fuzzy logic, crowds we can do. There's a bunch of things, but we're going to start with simple here. So first of all, we're going to add in an add node. What the add node does, it can add things to other values. So let's just start down here by having a constant, and we have another constant. We use an add, and we pipe these two like this. So if this constant is 5 and this constant is 2, the output of this, I'm just gonna bind it to an attribute so you guys can see. But the output of this is gonna be 2 plus 5 plus 2, since it's an add. And the output of this is gonna be, I'm just gonna call it test. And we can see in the geometry spreadsheet that test is equal to 7, which means that 5 plus 2 equals to 7. Never mind this part. I'm gonna explain this more, how to output attributes, but I just wanted to show that how the add node works. I'm gonna delete these. So here we have an add. We have piped the position to the first input, and we have piped a constant set to a vector to the second input. As we remember, position is a vector, so it has 3 values instead of 1 value. And this means that we wanna use a vector and we wanna add a vector to it. The add node can totally fine do that as long as both inputs are vectors. If only one input, the first input is a vector and the second one is a float or integer, we are only gonna add the integer. Actually, let me check that. I think we only add the integer to the first input of that. No, actually, if you put a constant like that, you're gonna add this number to all vector values. So in X it gets +1, in Y it gets +1, and in Z it gets +1. We are simply in this example want to add a 1 to the Y position. Therefore, we're gonna use a constant and set it to 3 floats vector. We're gonna set 0, 1, 0, and we're gonna pipe it to the second input of the add. And then we're gonna pipe this to a like it isn't necessary to pipe to a switch, but I've done it here. And for the input 0, I'm gonna bring it to scene view. We can see that we have the original position here. If we put it to 1, which is the actual input of the add node here, input 1. Or well, it's input 2 actually, but whatever. Switcher index 1. Anyway. If you pipe that to input 2 and put the switcher index to 1, we can see that if you visualize that, we can now see that the points have moved up 1 for all the points in Y. Again, we can also do this by subtracting. So we have a subtract node as well. We have an add, we have a subtract node. So for the subtract node, this works exactly the same way. So if you find a constant here, that is like 1, you're gonna subtract 1 from all the values. But since we wanna only subtract 1 in Y direction, we also use the same vector. We put it to 0, 1, 0, and we pipe it to the second input of the subtract. This is gonna subtract 1 in Y for all the point positions, okay? So if you now switch this to switcher index 2, we're gonna see that our points have been moved down 1 in all, for all of them in Y direction, okay? And there you go. So yeah, that's kind of how add and subtract is used. They're very useful, both of them. I use them all the time when I do stuff in VOPs. So yeah. Yeah, and then how you output these positions and stuff like this is by connecting the add, or actually the switch in this case, to the same like attribute as you want to output it to. So if I have a position and I want to add stuff to the position, I do an add, I do all my things here, and then I output the vector back into to the positioning geometry VOP output. Okay, so you can see it goes into the position and that updates the position of the points. So that's basically how simply this node, the VOP, works and how you can modify point using it. All right, thank you guys. See you next tutorial.